everyone. As you can tell from my voice, I'm still sick. It's before Thanksgiving and I still have my cold, but I'm going to do my best to give you a very quick overview of our unit. This is just the review video. So what we did in this unit was we talked about functions. And we said functions are relations or ordered pairs where the x's are all unique. So a function can have no repeating x values for something to be a function. And then the two different kinds of functions, it can be one-to-one, which means no repeating y values, and it can be an onto function if it utilizes all the y's. So for functions, all the x's are different, are unique, let's say. A one-to-one function, all the y's are also unique. An onto function utilizes or uses all the y values. You can have just a finite function, which is just something like 2, 3, 4, 7. It just has two ordered pairs in it. You can have an equation that creates a function like this. This makes a line. Or you could have just some kind of weird squirrely graph that they give you, anything like that. And you have to just be able to determine if it's a function or not. If the answer to this one is no, remember that it can't be a one-to-one or onto function because of their specific types of functions. So if it's not a function, those are automatically no. You need to be able to make a sketch or graph if it's an equation and read the domain as the furthest left to furthest right, range lowest number to highest number. If it looks like this or this, if it's this, first thing, a finite set, my domain is just 2 and 4. My range is just 3 and 7. So it's just those two values in the curly brackets. Here we used either the interval notation or the set notation, something like that, which indicated it was all values in between those two numbers, because this is a huge, obviously an infinite number of values. This is just 2. All right, so that was day 1. Function, one-to-one, domain, range, and all those types of things. Day 2 was restricted domain. There were 3 special restricted situations: fractions, radicals, and fractions with radicals. Make sure that you understand the difference when you set things to 0, when you write all real numbers except, and when you just set to greater than. So fractions was all real numbers except the undefined value. Radicals, you took what was underneath and you set it to greater than or equal to 0. Or if you set it to equal to 0, then whatever number you got, you did that number, comma, infinity. If it's a fraction with a radical, we did the same thing. We set that to 0, but we did that number, comma, infinity, but with a parenthesis this time. Or we just set what was underneath to just greater than 0. So review those videos or your notes from the stations on that if you need to. If it's not one of those 3 situations and it is a function, then the domain is all real numbers, or negative infinity to positive infinity. Those mean the same thing. After that, we talked about types of functions. Types of functions were on that big chart that you had. A constant function is just y equals like -3 or y equals 14. A linear function, of course, has an x and a y to a single. A quadratic function, an absolute value, has an absolute or a radical. One type of step function that we looked at was the greatest integer function, which looked like that. And it made the picture that looked like steps, of course. So you should understand domain and range and the question of, is it a function? Is it one-to-one? Is it onto for all these different types of equations? Remember, of course, you have the graphing calculator. You can type it in and take a look at it visually and get a look at what's going on with the domain and range. But it's also good to know just by looking at this absolute value without the calculator what it's going to look like. The absolute value makes a V. Since this is +2, I know that this is going to be over here at -2 because this represents the left-right move, and it's actually the opposite of what it looks like, just like before. And then we had all that function notation. We had f of 8 when f of x is, I don't know, 2x minus 1. And if they asked for f of 8, you would just do 2 times 8 minus 1, or 15. We had composition. That's when they gave you two different kinds of functions. Suppose this is like, I don't know, x plus 7. They could ask for f composed with g of 2, or they could ask for f composed with g of x. Both of these mean the same thing, the little circle or the double set of parentheses. You would do this first, so you would do g of 2, which would be 2 plus 7 or 9, and then you would find f of 9. So you'd go to function f and plug in 9. 2 times 9 minus 1, which will be 17. If they ask for f of g of x, I would take this entire thing and plug it into f. So I would take this entire thing and plug it in right there for x. So f of g of x would be 2 times x plus 7 minus 1, or 2x plus 14 minus 1, 2x plus 13. That's composition. And then on the last couple of days, we talked about the inverse of a function and then direct and inverse variation. Inverse of a function is when you just switch the x and y values. So obviously, if it's something like this, real simple, and that's the given function, the inverse would be just reversing the x and y values. Because this was a one-to-one function, it means the inverse is now a function because the y's were all different and they become the x's. So if this is a, and this is a inverse, if a is a one-to-one function, it guarantees that a inverse will be a function as well. If they had given you something that's in the form of an equation, to find the inverse, you have to substitute a y for f of x. Again, interchange the x and the y values, and then solve it for y. So to get rid of that squared, I'm going to square root both sides. Here you have to remember that good old plus minus, and I would replace this y with f inverse notation because I was in function notation to begin with. So that's how we found the inverse of an equation. The last thing we had was direct variation versus inverse variation. When two letters vary directly, let's say it says T varies directly as P. Find T when P is 14, if when T is, You're going to look at your letters and set up either a proportion or a multiply depending on this word. Direct means divide. We said direct divide. So I'm going to write T over P equals T over P. And then if it says something like, when T is 4 and P is 15, find P when T is 2. You would just cross multiply. You would just fill in T and P on one side, T and P on the other. If instead it said T varies inversely or indirectly as P, then you set up multiplication. T times P equals T times P, and you would have 4 times 15 equals 2 times P, and you would solve that. I think that's it in a nutshell. I feel like that's a real quick kind of review, but it's the domain and range and functions, lots of visual stuff, inverse functions, domain and restricted domain, direct and inverse variation, and of course the inverse of the functions. If you grabbed the extra 2 worksheets to work on, I'm going to put the answer keys underneath the camera. So now is the time to pause, and the answers will be under in 1 second. I didn't do a new special fancy version. It's just my answer key from my notes. So you'll see both interval notation and set notation, whichever one you prefer. Thanks. Have a great afternoon. Study hard, and I'll see you tomorrow.